Hi boys and girls, today we're going to go over Ratio Quiz 3, which was a partner quiz. We're going to start with number 1. There was some information we're given that's cut off here, and the top of the question, it says, in the cafeteria the school aides noticed that there were 8 pizzas served for every 2 minutes. Create a table to determine how many pizzas the cafeteria probably had after 1 minute of serving food, based on how many were served in the first 2 minutes. Using this relationship, predict how many pizzas will be served after 4, 5, 6, and 15 minutes. So this is a picture of somebody's quiz, and they made a ratio table here, and they put minutes on the left, pizzas on the right-hand side. The ratio that they should have started with is 2 to 8, and from there they created the ratio of 1 to 4 because we can divide 2 and 8 by 2 to reduce it to simplest form. And from there they continued the ratio table on. The minutes was increasing by 1 each time they entered a row, and for the pizzas they were increasing by 4 each time they entered a row. After they created their table, they went up to 15 minutes. Then they listed their answers over here on the right hand side for the question, which was how many pizzas in 4 minutes? That's 16 pizzas. 5 minutes had 20 pizzas, 6 minutes 24 pizzas, and 15 minutes had 60 pizzas. And their original table showed that in 1 minute there was 4 pizzas. Number 2. The cafeteria cooks also make brownies, and their recipe uses 4 eggs for every 2 cups of flour. What is the ratio of flour to eggs? Flour needs to come first, and then eggs second. So that's 2 to 4. You could have written it with the words 2 to 4, or as a fraction 2 over 4. Those all would have been acceptable answers. Next, complete the table to determine the ordered pairs. Use the ordered pairs to graph the relationship of the number of cups of flour to the number of cups of eggs. So we have here in our ratio table the number of eggs starts with 4 and increases by 4 each time. The multiplicative relationship is times 2. And here the ordered pairs are listed right next to it, so we know what to graph. Now if I erase this information here, we talked about it this week, that in our for every statement, whatever comes after for every should be our independent variable, and that's our flour. So the flour needs to be on the x-axis, and our dependent variable, the eggs, should be on the y-axis. You'll notice that we have an even scale down here. We're starting at 0 and increasing by 2s each time. And for the y-axis, we're starting at 0 and increasing by 4s for each box as we move up. From there, we're plotting our points that we listed from our table, and we have a nice straight line. The next part says, what would you do to the graph in order to find how many eggs would be needed if the recipe was larger and called for 24 cups of flour? So the response here, in order to find the number of eggs that would be needed if the recipe was larger and called for 24 cups of flour, I would keep on adding more numbers of eggs to the grid until I got to 24. Now that word actually should have been flour, because we have 24 cups of flour. And then I would keep on adding cups of flour. We're going to change that to eggs to the grid. While doing that, I'll keep pointing, we should say plotting, the ordered pairs in which they match up. The number of eggs would be 48, and the ordered pair is 24, 48. So the only thing we would have switched is 24 cups of flour, and we would keep on adding 4 for the number of eggs each time. Number 3. The school aides also noticed that for every 5 chocolate milks taken by students, there were 10 juices taken by students. Complete the table below. So we should have 10 for juices and 5 for chocolate milks as our first entry. Our juices are increasing by 10 as we move to the next row each time, and the chocolate milks are increasing by 5 as we move down to the next row. What is the multiplicative relationship or constant number C that makes these ratios equivalent? the multiplicative relationship is the right column is multiplied by 2 to get to the left column. We're multiplying the chocolate milk by 2 to get to the juices. You could have said the multiplicative relationship is dividing by 2 going from left to right as well. That would have been acceptable. And the last part, using an equation to represent the relationship between the amount of juice, J, and the amount of milk, M, taken by students at lunch. So we have the milk times 2 equals the juice. And if we rewrite it, this also would have been acceptable. 2M equals J. Some of you also wrote J divided by 2 equals M. That works as well. And the last question. The cafeteria cooks were making macaroni and cheese and noticed that they use 6 ounces of cheese for every 2 ounces of milk. Use the table below to create ordered pairs that can be graphed on the coordinate plane below. Our title is macaroni and cheese. We can add the word recipe to it because that's what we're working with. The milk is on the x-axis, the cheese is on the y-axis, and the reason for that is what comes after the word for every is milk, so that's our independent variable. We hadn't talked about dependent variables and independent variables when you took this quiz, so if you have cheese on the x-axis and you have milk on the y-axis, that would have been fine. Now, our x is always the horizontal, and our y is always the vertical axes. And from there, we're plotting the points to make a straight line. You'll notice that for every box, we're increasing by 2 for the milk on the horizontal axis, and on the vertical axis, we're increasing by 6 when we start at 0 as we move upward. And the points form a straight line, so we've joined that to make a nice line. If you have any questions on this, please see me in class. Have a good day.